The lesson is standard form of a quadratic function, and this is lesson 4.2. We have two goals in this lesson. One would be to graph and write in vertex form, or one is to graph and the second one is to write in vertex form when we're given standard form of a quadratic function. So first of all, we need to identify what is the standard form of a quadratic function, and that is ax squared plus bx plus c. And in order for that to be a function, we write it in function notation. So f of x equals. In this case, in order for it to actually be a quadratic function, a cannot be 0. Otherwise, we would no longer have a squared component, and that would be then a linear function. If a is greater than 0, we've already talked about the parabola opens upward. And if a is less than 0, so now a is just in a different spot, a is less than 0, the parabola opens downward. The axis of symmetry is the line, so we actually have an equation now that we can use to create that axis of symmetry, and that is going to be negative b over 2a. So we formerly wrote x equals, and we were able to easily identify the vertex because we were in vertex form. Now it's a little bit more involved. We look at the coefficient of our x term and then take the opposite of that and divide it by twice the coefficient of our x squared term. The x value of the vertex is actually just the same thing. So x equals negative b over 2a, which makes sense given what we just talked about. The y value of the vertex then would be if we plugged in the x value into the function. So that means plug in whatever you came up with for the x value of your vertex, plug that into the function. So here's an example. What is the graph of y equals x squared plus 2x plus 3? We know that if we have our vertex and we have the lead coefficient, if that's just 1 or negative 1, then we have a quick and easy way to graph that. So the first step, identify a, b, and c. So we have a here would be a 1, b, and c. So actually write that out. A equals 1, b equals 2, and c equals 3. Next is find the axis of symmetry. So we'll plug in negative b over 2a to get the axis of symmetry. Negative b, so that's going to be negative 2 over 2 times a, 2 times 1. When we simplify that, 2 divided by, or negative 2 divided by positive 2 is going to be a negative 1. So we have x equals negative 1 as our axis of symmetry. We just define our axis of symmetry, and our x value is the exact same thing, so we can just rewrite that for finding the vertex. We already have the x value as negative 1. To find the y value then, we need to plug in the x value back into our function. So we'll plug negative 1 in to find out what y is. Y equals then x squared, so negative 1 squared, plus 2 times negative 1, plus 3. So negative 1 squared is 1. 2 times negative 1 is negative 2. Add the 3. And then 1 minus 2 is negative 1. Plus 3 would be a positive 2. So our y value for our vertex is positive 2. We now have the vertex of the function. So we can plot the vertex. So you'll want to have graph paper for this part. So we have negative 1, positive 2. And let's go ahead and write out, this is our example with y equals x squared plus 2x plus 3. You always want to write your equation near your graph. And then by noticing here that our lead coefficient is a positive 1, we can just go over 1, up 1, left 1, up 1. Over 2, up 4. Left 2, up 4. And there's our parabola. So that was our first example. Not too bad. Next thing we'll do is we'll try one more example. And I'm actually going to do the whole thing right here. So our next example is, we'll call this example 2. And this one is negative x squared plus 2x plus 5. So looking back through our steps, it's good to keep these handy. Step 1 is to identify a, b, and c. So we'll do that. A here is negative 1, b is 2, and c is 5. So that's step 1. Step 2, we want to find the axis of symmetry. So that's x equals negative b over 2a. Sometimes helps to actually write out the formula to remind us what goes in there. 2, so we're going to take the opposite of 2, divide that by 2 times negative 1. So that's a negative 2 divided by a negative 2, which is a positive 1. So now we have the x-axis of symmetry as well as the x value of our vertex. Step 3 then is to find the y value of the vertex by plugging in our x value. So y equals negative x squared plus 2 times x plus 5. So y equals, we square the 1 first and get positive 1, then take the opposite, so that's going to be a negative 1 plus 2 plus 5. Negative 1 and 2 is 1, plus 5 is 6. We now have the y value of the vertex. So our vertex is at the point 1, 6. We'll plot the 1, 6, 1, and then double check, is this opening upwards or downwards? Since we have a negative a value, we know it opens downward, and it's a negative 1, so we have our standard over 1, down 1, left 1, down 1, over 2, down 4, left 2, down 4. And there's your graph.